Today we're going to talk about graphs and banking. The idea for this really is to encourage graph thinking and help people who may work in the banking industry understand how their data naturally forms graphs and how graphs can improve their business in a number of areas, as well as Sabine said in her intro, where there's an opportunity for using graphs, with more advanced data science techniques like machine learning and AI. So we'll start first with an introduction to graphs and Neo4j, just to make sure everyone is on the same page. Then we'll take a look at an overview of the sorts of data that a bank would have that will then carry forward into some particular use cases. So we're going to drill into 4 use cases for graphs and banking. First will be fraud, and with that we'll see a demo. Then we'll talk about risk, knowledge graphs, and the customer 360-degree view. In each of those, we'll take a look at a graph put together from the types of data we talked about earlier, and we'll explore how that graph can then be used for each of these particular use cases. And then we'll wrap up with some Q&A at the end. So to introduce graphs. So everyone is probably familiar with relational databases. They've been around for ages. It's what many businesses run on. They're really kind of quite structured, columns and rows, powered by the SQL query language. So you select some values, some columns from a row that matches a particular value, and you get that data back. Right? So very table oriented, a lot like spreadsheets. You put data in, you get data out. If you want to join entities together, you can do that with joins and join tables. There's a known design pattern for this, normalization, but that joining of very complex sets of relations together can really be quite slow and cumbersome and difficult to build a query for. On the other side, we have graphs, and graphs are really built for connected data, highly connected data, right? So where you have very connected data sets, entities that are linked with other things in very complex ways. Graphs can help you leverage the context, the additional information that's held in those relationships. And the query language for that is Cypher. It's our query language from Neo4j, and you can see an example of it there, where there's someone named Anne who loves someone named Dan. Today, we're not really going to get into Cypher as a language. We're really going to focus on the graph data model and understanding that representation of data. So, the idea of graphs is, as I said, leveraging the power of the relationships between data. And in Neo4j, we always say relationships between data is as important as the data itself, right? And we believe the next wave of competitive advantage in businesses all around the world and across all industries will be powered by using those connections between data to identify and build knowledge. And what you see here is a graph that spans data silos, right? So often the relationships between your data can be difficult to see and certainly difficult to use because your data lives in all sorts of different databases across your business, right? So you have customer data, you have your product data, you have third-party data like market data, maybe social media data, credit agency data, joining all this together in one coherent view to allow you to leverage the power in those relationships is what Neo4j offers. So you might be thinking, how can graphs help me then, right? So we're going to take fraud as an example. In the olden days, fraudsters were maybe less advanced, right? Before there was the internet and all the technology we have available now. Fraud was maybe more straightforward, and so were the techniques used to identify it, right? So if you have a loan fraudster, maybe steals someone's credit card, goes out and starts shopping with it, we have techniques to be able to find that sort of transactional fraud. Fraudsters have grown, advanced over the years, and the techniques they use are now much more advanced. The technology they use is a lot more advanced. So the problem is you got to find these guys, right? You have to find a fraud ring. Fraudsters now often work together to try to fly under the radar to avoid the old techniques that were aimed at old fraud, and instead, are using their new techniques, working together. And what you need to do is find the patterns in your data that can show you the behavior of that fraud ring. And that's what Neo4j really does, right? We are the #1 database for connected data, an enterprise-grade graph database, and we say we're a native graph database, which means we are built explicitly for working with graphs, for working with connected data. And everything about our database from the ground up is really engineered to work with those relationships in that highly connected data. So we allow you to store that data, to access it, to understand it, to traverse it, to visualize it, and to manipulate it live on the fly, right? Add data very easily. It's highly performant, it's scalable, it's everything you would expect from an enterprise-grade database. So to introduce the concept of the graph data model for anyone who's not familiar with it, it's really built of 3 very simple components, right? So first, there are nodes, and that's what we see here. The circles, we have 2 person nodes, and we have 1 car node. Nodes in the property graph model tend to be nouns, they're things, they're entities. And the labels that we have on them, person and car, are just a way of doing that, of labeling them so that they're easy to query and group together, but it doesn't necessarily imply any kind of schema. So like in the relational model where your schema is fairly rigid, every row has the same columns in it, and if you don't have a value for that column in a particular row, you have to fill it with null. Graph databases are more flexible, so one person node doesn't have to look exactly like another person node. Between them, we have relationships. So we can see here, this person loves this person here, and this person loves this person here. Relationships are always saved in the database with the direction. And you can see that with the arrows here. And each relationship can only have 1 label. So you couldn't have loves and lives with in the same relationship. That's why we have 2. The directionality is sometimes important. So for example, loves is important, right? So we have this person here, whose name is Dan, loves this other person named Anne. Luckily for him, Anne loves him in return, but if she didn't, that relationship would go away. So it's important to know the direction of that loves relationship. Whereas lives with, it's kind of implied that it's bidirectional. So if Dan lives with Anne, then of course Anne lives with Dan. It would be logically impossible for it not to be that way. So we can ignore the direction at query time, and therefore we just need the 1 relationship. So we have nodes, relationships, and the last part of a property graph is the properties. So that's what these are up here. Nodes can have properties as well as relationships, and properties are just key value pairs. So here we have a property called name, and the value in that is Dan. We know Dan was born on May 29th, 1970, and we have his Twitter handle, which is @Dan. We know this person has a name property of Anne. She was born December 5th, 1975. We don't have her Twitter handle, and that's okay. Like I said, there's no schema enforced out of the box, although you have the choice to apply a schema to your database. If we get Anne's Twitter handle down the road, it's very easy to add it. If instead we want to add her Instagram account or her Facebook account, we can do that too. And we can see as well, there's a property on this relationship. So Dan drives the Volvo that Anne owns, and he has driven it since January 10th, 2011. So those few components give us all the tools we need to be able to build a really complex and expressive graph data model, which we'll get into in a bit. We're really going to focus today on nodes and relationships, a little less than properties, although as we go through each of the graphs we're going to look at, we can talk about the sorts of properties that would be there. So now we're going to take a look, just a high-level overview of the sorts of data that a bank might have before we then start putting that data into different graphs. So first, we'll look at organizational data, and this is data that you as a bank hold, about yourself. Really, it's about your business. So you probably have lots of documentation, and that can live all over the place. Maybe you have SharePoint, maybe you have an intranet. You might have documentation at various levels. So you could have global documentation, regional documentation. Then there's processes, and the same would be true of that. You probably have global processes as well as more regional processes. You'll have employee data and information about the people that work in your company, as well as the organizational hierarchy. So where do those people fit into your organization? Who reports to whom? What projects do people work on? Then you'll have KPIs and reports. Obviously this is really important for running your business, understanding how those KPIs are calculated, how you report those internally, as well as reporting them to regulators and governing bodies. And then you have systems and databases. So this is where your data actually lives, or the applications that you actually use to run your business. Next, we have data about your customers. So you'll have personal data about them. Maybe you know where they live, their phone number, so when they were born, so on and so forth. You'll have some documents from them. So this might be the documentation they provided when they opened their account or when they applied for a mortgage. You might have some information about their relationships. So you can see here is already a little graph. Maybe you know their spouse, maybe you know details about their children, any information you have about other people they might be related to. So far, we've been kind of really talking about personal data, right? This is kind of retail banking. But of course, you could have commercial banking data as well, right? So you might be working with companies. You'll have information about those companies, their corporate data. And we'll explore both scenarios. I think most of it we're going to focus on retail banking, because I always think that's kind of the most relatable. Most people have a bank account and work with, interact with a bank, and so they understand those processes. But we will look at a particular scenario for corporate banking as well. And then you might have information about assets, especially if you're looking at corporations or businesses, but also individuals, right? If they put up security for loans or something like that. Next, we have information data about your products and your services. So again, you have documentation about those products and services, processes related to them. What is the process that you go through when someone applies for a current account or a mortgage? You have the details of specific products and services, as well as the hierarchy. So you might have, an extensive set of services and products that you've offered over the years. You might have like a closed book of services you don't offer anymore, but people still have them. So being able to relate all those together and understand the details of each of those products or services is quite important. And then you have the information and knowledge that you use when you're pricing individual products and services. Next, there's event data. So I've kind of grouped together a few things here. There's money movements, transactions. There's web and app activity that you might be tracking when someone logs into their banking website or uses an app. And then there's call center or customer contact information. And lastly, you might be using third-party data. So you maybe track social media mentions of your bank, of your organization. You certainly interact with credit rating agencies, both for retail banking as well as for corporate customers. And then there's market data again, which is more in the commercial banking space. You need to watch the market movements and understand how that will impact your business. So certainly not an exhaustive list, but this will definitely give us enough to work with where we can understand how you can build graphs from all these different bits of data to then power individual use cases, right? And again, it's important to remember this data could live in a number of different systems across your organization. And so if that's true, if you have very siloed data sources, and right now it's probably quite difficult to join together all this data and to get that holistic view that you need for these individual use cases. So hopefully you'll start to see how the graph can really change the way that you can run your business. Okay, so first we're going to look at fraud. So this is a graph that I've built to illustrate, the sorts of data you might use for detecting fraud or for investigating fraud. I built this using a tool. You can see there's a link on the bottom here, and it will be included on the resources page at the end. But we have a tool called Arrows, which some of my colleagues have built, and it's a really great tool for kind of dragging and dropping and visually building a data model in a browser. So it's quite convenient, right? And here we have the color coding matching the different classifications of data that we talked about before. So you can see on the right-hand side, we don't have any organizational data in this particular fraud example. So this is really looking at the potential for credit card fraud or money transfer fraud or something like that. You could, of course, have a separate graph that would include organizational data if you were looking for fraud inside of your company, right? If you were looking for your own employees who might be committing fraud. So here we have in blue some customer data, right? What you know about your customer. So here we have a customer. That customer has some documents that they've submitted. So we have a copy of their council tax statement and their passport from when they set up their account. We know their home address and we know their phone number. Right? So when we look at our fraud demo, this information is quite useful during, this is the information you gather during KYC, know your customer as you're setting up an account. And you can use this to then detect fraud. One of the ways that fraud rings operate is by signing up for multiple accounts. And they do this using bits of synthesized identities, bits of real identities, so that when they sign up for an account, it looks real, but actually maybe some of that information is stolen or it's being reused. It's really difficult to fake one complete false identity that will pass through the KYC checks. But using synthesized IDs or bits of real IDs, fraudsters have a better chance of success. Then in green, we have some information about the products that our customer has. So here, for example, this customer might have a current account. They might have a credit card through their bank. That current account has a debit card. And then all the rest of the data that we have round about here is event data, which is not surprising, right? Fraud investigations, fraud detection is usually driven by suspicious events that happen around an account. So starting here at the bottom, we can see this credit card was used at an ATM to get a cash advance, to take cash out from the credit card. So that may or may not be suspicious behavior for this particular customer. We're not showing properties here, but you might want to know where this ATM was located. Is this customer typically in that area? Is this ATM has it already been flagged as suspicious? Has other fraud been associated with that ATM? These are the sorts of things you would want to look at. Here we have some purchases from 2 different retailers using that credit card. Again, you would want to look for a pattern of suspicious behavior. Often what people do, fraudsters do, when they get a hold of a credit card information or debit card information, they might make a few small transactions to verify that the card works before going all in and buying, something really big, really, going through the balance of that credit card. So you might be looking for patterns of transactions that would indicate potentially fraudulent behavior. Or again, you might look at these retailers and understand if they've recently been associated with fraud on other customer accounts. Same goes here with the debit card. It was used to make 2 purchases at a retailer. The same things apply. Cash withdrawals from a different ATM. So again, you'd want to know the location of that ATM. This is probably less suspicious. You've got a money transfer into the current account from that person's employer. But then we have a money transfer here that was made during a web session by this customer from a particular IP address, and the money was transferred to a foreign account. And again, that may or may not be suspicious, depending on the typical patterns of behavior for that particular customer. And again, whether there's anything about that IP address or that foreign account that ties it to other incidences of fraud. So hopefully you get a sense of how the connections between these different pieces of data can actually be used to, to do some really advanced investigations around fraud, looking for patterns of behavior that are unusual, or if you've identified some fraud before, seeing if this matches that same pattern. So, to think through how we might use this, right? You might be thinking, can I find patterns in the graph indicating fraud in a particular account? Yes, I think we've talked about how that can be done. You can look at one account, look at all of the activity and the patterns in the data around that. If you find something that's suspicious, maybe withdrawals in short time frames from multiple ATMs, purchases from different IP addresses as well, using that same account, going to suspicious ATM machines that have been linked to fraud before, looking for a pattern in a particular account is definitely a use case here. Then the next question is, if you find a pattern of fraud in the graph for one account, can you then look for that pattern on other accounts? And the answer is yes. Once you identify a pattern that says, when I see these things happening, then you can apply that pattern to your entire graph, all your customers, all your transactions, and see where else that pattern appears, right? So then you can find more incidences of fraud, potentially, that you hadn't known about before once you identify that pattern. Next, you might think, okay, I've detected fraud, but can I use this same approach to prevent fraud? And the answer is yes. So once you've identified a pattern that is typically fraudulent, right, or that is at least worth investigating, you can then set up alerts. So as you see that pattern starting to form, you can raise an alert and you can prevent fraud, right? So it's kind of shifting from detection after the event into prevention, being more proactive, stopping fraud before it happens. Again, by identifying patterns of behavior and being able to spot those patterns as they develop. And then lastly, could you use this graph alongside some more advanced data science techniques, things like machine learning, to find new patterns of fraud you didn't even know about? And the answer is yes. This is a really exciting area for us and for graph databases in general. The ability to link the graph with machine learning, really is more powerful than the sum of its parts. So the graph can be used to feed information into your machine learning pipeline. So you can identify features and their relationships in the graph that you can then feed into the machine learning pipeline, use that machine learning to find patterns, to create a model that can then be applied back to the graph, right? So you can use that to identify new patterns of fraud, apply that into the graph, look for those patterns where they may exist. Again, try to prevent those patterns from happening by spotting them as they form. And then that becomes a loop. Right? So as more data gets added to the graph, you can see how successful that machine learning model is. You can then feed the graph back into your machine learning to refine it and continue that cycle, continuously looking for new patterns, improving those patterns using that loop, that feedback loop between the graph and your machine learning pipeline. Okay, so now we'll take a quick look at a fraud demo in Neo4j, just so you get a sense for how you might actually use the database. So this is a tool called Bloom. This is a more business user-friendly way of interacting with Neo4j, where you don't need to know the query language. It's all powered by this search bar, and I've set up a few queries for us to take a look at. So first, we're going to look for some fraud rings. Right? And I can show you the query for this. It's something I've written in Cypher, as I said before, our query language. I typed in find fraud rings, which is the search phrase, and what it does is it kicks off this cipher here, which basically looks for rings of individuals, rings of account holders in our database that share contact information amongst themselves. So we can take a look at a few of these and see why exactly they've shown up in our query results. So first we have 2 account holders, no, 3. We have Carolyn, we have Simone, and we have Jay. Jay and Simone share a phone number, not uncommon, maybe they live together. What is uncommon is that they also share a social security number. So in the US, social security number is a unique identifier. It shouldn't be possible for 2 people to have the same social security number. And so therefore, straight away, that's a red flag. Right? Carolyn shares an ID with Simone. So both Carolyn and Simone have submitted the same passport details. Whereas Carolyn has her own social security number. And we can see Carolyn and Jay and Simone all have the same address together, right? So this is an example of what I was explaining before, synthetic identities, shared bits of identities being used together to set up accounts. We can take a look maybe at one more example. So here we have 2 individuals, Kathy and Chang. They share an address, again, not very unusual. What is unusual is that they have the same driver's license details. Their ID is the same. So again, another red flag, right? 2 people can't have the same driver's license detail. Bruce here shares a phone number with Chang and Kathy. So even though he doesn't have the shared driver's license or indeed any kind of major red flags, he is implicated in this ring because he shares a phone number with Kathy and Chang, right? So even though he doesn't share passports or driver's license or whatever, we would still think he's probably part of this ring because he's tied to the other 2 by this relationship with the phone number. Okay. Just to show you a little bit more about how Bloom works, we can drill into some of these entities. So if I double click on Chang, I can see the properties associated with him. So these are his details, his birth date, his full name. He has a unique identifier in our system. I can see all of the relationships that are associated with him. So they, I don't think they're all out, no. And we can see the neighbors. So these are the nodes that sit at the end of those relationships, and we can see some of the details for those. If I wanted to, I could then reveal any that are not. So his bank account details weren't out. I've not brought those out on the display. Okay. We'll take a look then at another type of fraud. So this is more kind of e-commerce oriented fraud. This is using transactions that look suspicious to identify potential fraud. So we'll start by saying find e-commerce fraud. And what this does is it's pretty straightforward. It's just looking for events that happen within a certain time of each other, so here we have a particular card, a bank card that was used in 2 purchases. This one at 09/55/13, and this one here at 09/55/09. So within 4 seconds of each other from different IPs, which are located in different US states. So potentially suspicious, maybe you need to know a little bit more. It could be a parent and their child who are using the same credit card, the same bank card. So we have some additional details here. We can see the accounts that were used to make the purchases. We can see they were both delivered to this same address, which is in Maryland. Even though one of the purchases was in Idaho, one was in Rhode Island. So, again, this may or may not be suspicious, but if you tie this together with other information you have in the graph, it might build a bigger pattern of fraudulent behavior. We can also see e-commerce fraud with subsequent purchases, right? So we identified the behavior that we thought was suspicious, which was the 2 original purchases made from different IPs in such a short time frame from each other. But here we have 2 other purchases that were made subsequently, one at 9:58 and one at 9:56. If you think the earlier ones are fraud, then these 2, might also be something that you want to dig into and understand whether or not they could also be fraud. All right, so again, we have a third account, a third delivery address. However, this node down here at the bottom was made to the same delivery address. Maybe it's this one here that's the outlier. So it's quite a visual way to perform your investigation. Very easy for a non-technical user to be able to use, as long as you understand the domain and a little bit about the data model. It can be quite easy to visually explore the graph and look for patterns without having to know any code. Okay, so that was our Neo4j Bloom demo. Now we're going to go through a few more use cases, again, looking at the graphs that we can form from our banking data and understand how the graph can power these use cases. So next we'll look at risk. In this scenario, this is really focused on a business customer, right, rather than a retail banking customer, personal customer. So again, in blue, we have some information that we have about that customer. We know some information about their business. They own another business, so they have a subsidiary. We know some information about their primary contact, their phone number, their business address, so on and so forth. We also know who owns them and who the ultimate beneficial owner is, right? So this is quite important to understand how companies relate to other companies, particularly, if you're looking into anti-money laundering or, indeed in risk, if you need to know something that affects that subsidiary, if their business goes down or their business shuts down or they go into bankruptcy or something like this, it certainly could affect this particular business customer. We know their risk rating, which we have assigned them using our internal risk rating process. So here in red, we have more of our organizational data. We can see that this risk rating is aggregated up into a KPI, which is then included in a report, right, that would be given to the board or indeed maybe a regulating body. Here in black, we have some external data, some third-party data. So we have a credit rating that business gets externally, maybe from Moody's or something like that. We have information about their share price, which could certainly fluctuate. So we probably have lots and lots of instances of share price data about them, so we can see historically how their share price has fared. And maybe we have some press releases about them. Maybe we track information about this company in the news, or that they release to the news. Or it could be their quarterly earnings reports or yearly reports, things like that, so that we can understand how their business is doing and how that might impact their risk rating, right? Whether or not we need to adjust that. Then we have some product data about them. So they have a business account, they have a business loan. We can see they've made loan payments from that business account into their business loan. We can also see this foreign account has transferred money into that business account. And also this business account has transferred money to their owner's account. Right? So a little bit of event data, some transaction data. So what sorts of questions can we ask about this graph then? How might we be able to use it? Can we use the patterns in the graph to help improve the risk rating process? And I would say yes. The more you have a holistic view of your customer and all the data associated with them, and the more real-time that view is, the more effective you can be in your risk rating process, the quicker you can react to things that may be changing. So that's the answer to number 2 as well, right? To more quickly react to changes. If you're tracking external data, press releases, share prices, you're looking at patterns in the behavior of their accounts and money movements. All of these things will help you quickly react to changes that may alter the risk profile for that particular customer. So next, can you use the graph to understand the lineage of data which feeds your KPIs and your reporting? And the answer to that of course, is yes. When you know where your data lives, when you have this map across all your systems of your customer, and you know where the data lives, you can prove the lineage of that data and how it has been fed into that risk rating, and how then all of your risk ratings are aggregated up to a KPI and to reports. And so this is very important. Can you use the graph for regulatory compliance? And the answer would be yes. And BCBS 239 specifically is all about this, right? How you report risk, how you aggregate risk, being able to demonstrate you really understand how you determine your overall risk profile, where that data comes from, how you know that it's accurate, and how you know how it was calculated and aggregated. Okay. Next, we'll look at knowledge graphs, which is another kind of very exciting area for graphs. You can see this picture is very green. A lot of this is about product data. So this particular scenario is a knowledge graph that's customer facing. So here we have our customer, a retail customer. They have a current account, they have a mortgage, and they're interested in an ISA. Maybe they want more information about an ISA. So from their current account, there's a lot of information that we can offer them, right? So a knowledge graph is really a map of information. It's all the information that you have about your services, your products, their documentation, and building a map of that so you can understand how it all fits together and find the information you really need most effectively. So for current accounts in general, you might have general processes, you have a web page that has information about current accounts, maybe you have an FAQ page about current accounts. So this is all kind of generic information about current accounts. But here, because they have a specific current account, you need to know the definition of that particular current account, right? What are the things that make up their current account, and is it different from someone else's current account? Do they have a premium account or a gold account? Are there specific benefits that come with that account? Is there a specific fee? Are there any charges that get applied if certain criteria are met? So all of that product specific information is probably more interesting to this customer than some of the other more general information, unless they're interested in moving their current account. So we want to know, what are the processes that are associated with this particular product, and what is the documentation associated with that particular product. So if this customer comes to us and they want to know the information about their current account and all the details, we can get that information for them easily. Then we also see this current account is managed by a current accounts team who have specific contact details. So if this customer needs to reach out to someone specifically that they can talk to about their current account, this is how they can find that information. It's a very similar setup for their mortgage. We have a mortgage page, mortgage FAQs, some general processes about mortgages in general, and then we have the specific details about their mortgage product, right? What are the processes associated with that, and the documentation associated with their specific mortgage. And again, that's managed by a mortgages team with their contact details. If they're interested in ISAs, then the general information is probably where they want to go, right? If they don't have an ISA yet. So the general ISA processes, the general ISA webpage, and the general ISA FAQ will all be applicable to them, along with the ISA team and their contact details. So could you use that knowledge graph to then improve your customer's experience? And the answer would be yes. No customer wants to struggle to find information. So being able to get the information that they're looking for quickly and with accuracy is very important, right? So you can use this knowledge graph to power a search engine, right, to improve search results. Could you also use it with a chatbot as well as a search engine? Absolutely. We have lots of use cases. eBay in particular is a very interesting chatbot knowledge graph implementation where they use a knowledge graph that describes all the attributes of different products that are for sale on eBay, and the chatbot uses that knowledge graph to then make recommendations and have a conversation with someone about the products that they're interested in and what attributes might be most interesting to them. So if you're interested in implementing a chatbot, maybe for self-service help, building a knowledge graph to help that chatbot traverse all the information and find the most specific information that would be applicable is certainly a great way to go, and can really, again, improve your customer experience by giving them the right information in a very easy format. Could you use a knowledge graph internally as well? Absolutely. So we only looked at a customer-facing example, but you could do the same thing with all of your internal documentation. You can build a knowledge graph that describes the hierarchy of your company, all of the documentation that's available, and then again, you could use that to power search results, to give additional context, to be able to recommend documents that might be applicable to a particular person, or indeed, if you wanted an internal chatbot to help power that chatbot and give it an understanding of all of your information and how it's linked together, so that it can traverse that graph and provide the right information during its conversation at the right time. And finally, customer 360 view. So this is the idea that you want all of the information about your customer in kind of one easily accessible view, right? And whereas often this can live across a number of systems, right? So your customer data might live in a CRM system. The information about their accounts might live in another system. Event data like transactions could live in a payment system. So being able to gather all this information together in one place so that you can view it can be really powerful, and can really have an effect in a number of different places in your business. So this is the kind of the biggest and most complex graph that we've looked at. Again, still in blue, we have information about our customer. So here's our core customer here. We can see this customer has a spouse. They're married to someone. They both live at the same address, and they are both signatory to a mortgage. That mortgage was for the purchase of their home where they live. We can see documentation that they have associated with that mortgage. So here's their signed mortgage agreement. Here's the documentation that the spouse supplied, a passport and a bank statement. And here we can see the main customer supplied a passport and a council tax statement. You can also see the customer's marketing preferences. So maintaining this sort of information, particularly in the context of GDPR, is really important now, right? It's you need to know how your customer has given you permission to use their data and how you're able to market to them to remain compliant with GDPR. In black, we have some credit score information that would have been retrieved during their mortgage application. We can see that in addition to their mortgage, the customer himself or herself has a current account and a credit card. We can see each of those products has a specific definition. We can see a few transactions. So we can see the current account has paid into the mortgage twice, as well as an overpayment. And we can see the current account has some debit card activity, a few purchases from a single retailer. So of course, this is quite a small view, right? We have only one credit card purchase in our view, but normally you would have lots of historical data, and Neo4j does provide the ability to stamp all of your relationships and nodes with a time. So you can maintain a historical view, and you can also take a snapshot of the graph in a particular time range, right? So certainly there would be a lot more data that would sit behind this. And then lastly, in red, we have internal data, organizational data. We can see this customer has a mortgage advisor who works at a particular branch, and that customer uses that branch. And we can see there's been some customer contact as well. They've made some inquiries. So we have a record of all the contact points, all the times they've called into our call center or emailed us or what have you. There's even more information you can add to this. You probably have information about your customer's phone number. Maybe you have information about their social media interactions with you, if they've ever mentioned your organization in a hashtag or something like that. The idea is to have a map, a view of all your customer data, and then you can use that to improve your interactions with that customer. Could we use the customer 360 view to improve the customer experience? Again, absolutely, right? I personally get very frustrated when I contact an organization, especially when I've been doing business with for quite a long time, and the person at the other end of the phone doesn't really seem to know anything about me. Customers expect you as an organization to have access to all of their information, and they don't. It's not really their problem whether or not they're talking to the right division, or that information is held in another system. If you want a really smooth, and delightful customer experience, you really need all the information you can get about them in one place. And having this 360-degree view graph can really help you do that. What else could you use that graph for? Could you use it for anti-money laundering, for example? And I would say absolutely. Having that 360-degree view of your customer gives you a full view of all of their behavior and all the data you have about them, which can then be used to spot anomalies, right? So if you start seeing strange behavior, different accounts sending money into them, and they're not a business, then that could be suspicious, right? If they start opening all sorts of new accounts and sending new money all over the place, that could be suspicious. So when you have a full view of all their data, you can more readily spot outliers, different behavior than the norm. Can you use that 360-degree view to detect and prevent churn? Yes. So again, when you have that historical view and that complete view of customers' behavior, you can identify patterns that tend to indicate churn, and you can identify that potential churn in advance and work to correct it before it happens, right? So some obvious things that could indicate churn, someone starts draining their bank account and maintaining a very low balance. Maybe they're paying off their credit card or their mortgage from a different account rather than from their account they have with you. Maybe there's a series of calls into the call center, that have a negative score where they've called to complain. Maybe there's some social media activity where they're being negative about your brand. Whatever that looks like, if you can identify those patterns of behavior, again, potentially using more advanced data science techniques like machine learning, right? Using the data you have in the graph to inform your machine learning and then finding patterns of behavior that can identify churn. Then once you have that pattern or those patterns that indicate churn, you can apply them to the whole graph, find people who may be about to churn and correct that. Or again, set up alerts, right? Whereas you see a pattern starting to form, you can then be proactive. And then finally, can we use the customer 360 view to improve upsell and cross-sell? Absolutely. When you have a view of your customer, and a view of all your customers, you can start segmenting your customers, comparing customers to each other. If you have customers that look or behave very similarly, and a portion of them are buying a new product, maybe you can recommend that new product to others. Maybe you can identify a pattern that's in your customer's behavior that might indicate, maybe they have a new employer, they've gotten a raise, maybe they're in the market for a new house. All of these sorts of things you might be able to detect from patterns in their behavior, again, potentially using machine learning, and then proactively use that pattern detection to approach your customers for upsell and cross-sell opportunities. So there's other use cases that we could go into. For the sake of brevity today, we won't, but these are more general, I think, across a number of different industries. So there's identity and access management. It's sort of like an internal knowledge graph where you can understand your hierarchy when someone joins your organization, where they fit in, the complex relationships between global and regional reporting lines, what projects they work on, and so forth, and then identify, therefore, what systems and what documentation they need access to. We have a published use case from UBS on this. It's what they've done quite successfully. Right? I think they were able to reduce the onboarding time for new joiners, by weeks, so that when you hire someone, they're able to get up and running more quickly. Right? Infrastructure network management, managing your IT estate, understanding the connections between all of your servers and your networking equipment and being able to manage that. Master and metadata management, which is very similar to the customer 360-degree view that we talked about before. So being able to understand where all your data sits across all your systems, how it fits together. And then that, of course, can lead to regulatory compliance. So GDPR is very much about that, understanding your data, where it lives, being able to demonstrate that you're using the correct data, and that if someone wants the data you hold on them to be removed, that you know where that data lives in your various systems. And the power of the graph is really not just at the small scale that we've been looking at, very small graphs of a dozen nodes or something like that, right? The power of it is when your graph looks like this, when you've got to scale to the size of a very large bank, a very large financial organization, with lots of transactions, lots of customers, tons and tons and tons of relationships between them. That's really where the power of the graph comes into play, right? Where you can identify these patterns at that sort of scale across your entire business.